Hi guys, in this video we're going to working on page 307 problem 5 and page 312 and 313 problem 1. Okay, so I'm going to start with the remainder theorem. The remainder theorem provides a quick way to find the remainder of the polynomial long division problem. So if you use a remainder theorem, you can find remainder in quickly, so that you don't really have to spend too much time to do that. All right, so how can we do it? We're going to use this. So let's say my polynomial is gonna be written as a p of x, and then I would divide this one by x minus a. Then my remainder in this time, I just plug in a onto x, then I can get my remainder. Okay, so problem 5 in here, we're going to evaluate a polynomial which is finding remainder. Actually, you can do that in this way, because we can check it by using synthetic division if you want to, or you can just plug it into 3. So our book, they shared to use synthetic division. So it's up to you. You can do the either way. So I'm going to show you either way for this. My first way, my p of x is x to the 5th power minus 2x to the 3rd power minus x squared plus 2. I am looking for p of 3, right? So my first way, just simply plug in 3 into the expression. That's it. So my first method, plug in 3 onto x, which is 3 to the 5th power minus 2 times 3 cubed minus 3 plus 2. So 3 to the 5th power. What is 3 to the 5th power, guys? 3 times 3 times 3 times 3 times 3, which is 243. And then 2 times 3 times 3 times 3, which is 27, minus 3 plus 2. And then I have 243 minus 54 minus 3 plus 2. 243 minus 54, that would be 189 minus 3. Wait, hold on. 243 minus 54, which is 189. And oh, that was x squared. I didn't see because it got blocked. So 3 squared, that should be 9 here. And then here I got 9. Okay, so 9 plus 2, which is 182. That's my first way. Second way, you can do the synthetic division if you want to by using 3. Okay, synthetic division. You do 1, and then 4th power missing, cubed, x squared, x is missing, and 2. And then my x is 3, so now bring down 1, multiply 3, add them up. 9, 7, 21, 20. And then 0, which is a 60. 60 times 3, 180. 182. So I can get my remainder as a 182. So it's up to you that you can use first way, you can use second way. You can still get your remainder, okay? All right, I'm going to ask you to do got it 5 by yourself. So please pause this video. And then you're going to check your answer after resume this video, okay? All right, got it 5. Given that p of x equal x to the 5th power minus 3x to the 4th power minus 28x cubed plus 5x plus 20. What is p of negative 4? Which is plug in negative 4 everything. So p of negative 4 to the 5th power minus 3 times negative 4 to 4th power minus 28 negative 4 to 3rd power plus 5 times negative 4 plus 20. Okay, so negative 4 to the 5th power. What is negative 4 to the 5th power? 4 to the 5th power, that would be 1024, but my answer, negative 1024, minus 3 times 4 to the 4th power. 4 to the 4th power, that's 256. That should be positive. And then minus 28 times 4 to the 3rd power, 64, but that should be negative 64. And then minus 20 plus 20. Okay, so let's going. Okay, I cannot see well. All right, so negative 1024 minus 256 times 3, which is 768. That should be negative. And then 28 times 64, that should be 1792 minus 20 plus 20. And then negative 1024 plus negative 768, that become negative 1792. Oh well, so everything is going to be canceled out. So my remainder is 0. Okay? Alright, so if you want to do the synthetic division, please go ahead and you would get a 0 as well. Okay? Alright, let's move on to the 5-5. Theorems about roots of polynomial equation. Okay, so in this video, in this section, we're going to talk about rational root. Which is a root is what? The answer of the equation, right? So actually, we have many options of our answer, and then this rational root theorem will help us to get it which one would be our options to get our solutions. I know that getting the solutions is not easy. You are having a lot of time to try and then check, but once we know the rational root, which is the possible rational root, we are going to think about, oh, okay, my answer would be within this list. It should be within this list every single time. Okay, so this is the theorem. Please look at the book to page 312. All right, so the given polynomial p of x would be this: a n x to the nth power plus a n minus 1 x to the n minus 1 power, and then just keep going to the a1x plus a0. That's our p of x. Now, we're going to think about the possible rational root of this p of x. So you can see that the highlighted word in there, the rational root theorem. So how? That is, we're going to think about the quotient of the leading coefficient, which is xan, and then the constant. So here is the rule. Please look at the, keynote. So let p of x is an x to the nth power plus an minus 1 x to the n minus 1 power through a1x and a0 be a polynomial with integer coefficient. There are a limited number of possible roots of p of x equals 0. So first, what we need to look at it, integer roots must be factor of a0. a0 is what? Our constant. So at this time, the rational roots must have reduced form p of q, where p is integer factors of what? a0, which is our constant, and then the q would be factors of a to the nth, which is our leading coefficient. So look, this one is our constant, which is our last number, and an, which is our leading coefficient. So think about the factors of a leading coefficient and then on the constant. So now, let's look at the example together. So in this, take note, we are having 21x squared plus 29x plus 10 equals 0. So they are looking at the factors of leading coefficient, which is 1, 3, 7, and 21. But they are saying is we are going to look at the integer factors, which is a plus or minus 1, and plus or negative 3, plus or negative 7, and plus or negative 21. Samely, think about factors of 10, which is a plus or negative 1, plus or negative 2, plus or negative 5, and plus or negative 10. So we are going to combine them as a reduced form of p of q. What is my p again? Which is integer factors of our constant. So what is my constant this time? Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. That is gonna be my factors of constant over factors of leading coefficient, plus or minus 1, 3, 7, and 21. So after that, you're going to simplify this as plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10, and then under 3, plus or minus 1 over 3, plus or minus 2 over 3. Sometimes your answers are, duplicate, and then please skip that one, and then you are going to write it down, all of them. This time, we don't really have anything overlapped, so you can just write it down. And then, make it smaller. All right, now we're having plus or minus 1 over 7, plus or minus 2 over 7, plus or minus 5 over 7, plus or minus 10 over 7. Last line, 1 over 21. So these are all the possible answers, which is your answer should be within those lists. It's a lot, right? So which means you're going to, plug in these and to find out which one is going to be exact the answer. But look, actually they do the factorings. Their root would be negative 2/3 and negative 5/7. So those two answers are within this list. Yes, I can find out negative 2/3 is here, and then a negative 5/7 is here. Okay, so those are 16 numbers are going to be our possible rational root. And my answer needs to be within here. Okay, so I'm going to show you problem 1 to you so that we're going to use this rational root theorem. Okay, so problem 1 on page 313. What are the rational roots of 2x cubed minus x squared plus 2x plus 5 equals 0? What was our rational root theorem? We have to looking at our constant and then the leading coefficient. So think about factors of constant, which is a factors, constant, and the factors of leading coefficient. Okay, now what is our factors of constant? Tell me. Plus or minus 1, plus or minus 5. That's it, right? What about coefficient? Leading coefficient, plus or minus 1 and plus or minus 2. All right, so write it down as a reduced form. 1, 5, 1 over 2, and 1 over 5. So we are having total 8 possible, rational roots. Now my answer needs to be within here. So it's all like, trial and check and trial check. So if you are lucky, then you can get your answer right away. If you're not lucky, then you have to keep going until you get the answer. So I really recommend you that you can do the factoring, then please go ahead. It's going to be save your time a lot. But unfortunately, this one is not going to be factored out. Then you really need to find out the list from here. So if I give you, the strategy for this, I usually starting with the small numbers like 1. Okay, and then after that, I really, make my fractions all the way back because I really don't want to work a factor of the fractions a lot. And usually our answers are within the, integers. Yeah, of course, we can get our answers in the fractions, but it's take a long time. Okay, so I will try with 1 this time, and then I'm going to just, try the other answers. So actually the book, they already gave us the full chart of doing it. But if you're doing all of them, that took really, really, really long time. So we just, check by, just choose any number you like and then plug in. Okay. So I may starting with 1. Okay. So plug in 1 into my p of x, which is 2x cubed, x squared, 2x, and then 5. If it will become 0, then I already got my answer, okay? So, you don't really have to fully calculate it. You just find out that, okay, that will be 0 or not. But look, 2 minus 1 plus 2 plus 5, it will be 0? Nope. So I cannot do the x plus 1 this time. It doesn't really work. What about x minus 1 this time? X minus 1. So I'm going to use x minus 1, negative 1 this time. So 2 times negative 1 cubed minus negative 1 squared plus 2 times negative 1 plus 5. So negative 1 cubed will be negative 1. So I got negative 2. And then minus 1 minus 2 plus 5. Oh, negative 2 minus 1 minus 2. That will be negative 5 plus 5. Yay! We got 0. Right? So this is one of my answer. And then let's just skip the steps up for that, because after that you just plug in all the answers. 5, negative 5, half, negative half, 5 over 2, and negative 5 over 2. When you look at the chart in the problem 1, this negative 1 is only the answer, which makes a 0. So I can say the only rational root of 2x cubed minus x squared plus 2x plus 5 equals 0 is negative 1. And I know that I really understand that, this one needs a lot of work. Sometimes you really do them multiple times. Sometimes you did it like once, that's it. You really got it right away. But sometimes it takes long time to do that. So you just, you just keep in mind that, I may spend a long time working on the one single question. Okay? So the got it one. What are the rational roots of 3x cubed plus 7x squared plus 6x minus 8 equals 0? I know that you're going to have a lot of lists of the possible rational root, but I can tell you now, you are having only one answer, one only rational root this time. Okay, so I'm going to give you time to work on got it 1 by yourself, and then you can check your answer after you complete the question. All right, so got it 1. My question is 3x cubed plus 7x squared plus 6x minus 8 equals 0. All right, what was our rational root theorem? Please find out factors of negative 8. Even if we're having negative numbers, integer root is gonna be plus or negative the factors. So factors of 8, plus or negative 1, plus or negative 2, plus or negative 4, plus or negative 8, all over, I got what? 3 is my leading coefficient. So I have plus or negative 1, plus or negative 3. Combine them so that I can list a possible rational root, which is plus or negative 1, plus or negative 2, plus or negative 4, plus or negative 8. That's all under 1. Now what? Plus or negative 1/3, plus or negative 2/3, plus or negative 4/3, plus or negative 1/3. It's a lot. So 2, 4, 6, 8, 10, 12, 14, 16 possible rational root, which means if you are really, not make the good choice, that you really need to do the 16 times of it. Oh my goodness. So I just telling you that you may need a lot of time to finish one question. Okay, so now what we need to do, choose which number do you want to choose to plug in and then check it out, that which one is going to be make everything into 0. Okay, so I told you that your answer is going to be only 1 this time. And it doesn't look like it's going to be factored out. So unfortunately, you really need to use your gut to plug in numbers so that you can find your answer. Okay? All right, so let's plug in some of the numbers there. I already know the answer, but I'm going to show you some of it, and then you can really see that what is the right answer. Okay. Okay, since my board was froze, so I just had to restart it. So let me just starting over from the list. So the factors of 8 plus or negative 1 plus or negative 2 plus or negative 4 plus or negative 8 over plus or negative 1 and plus or negative 3. So you got plus or negative 1, plus or negative 2, plus or negative 4, plus or negative 8, plus or negative 1/3, plus or negative 2/3, plus or negative 4/3, plus or negative 1/3. And I told you that your answer is just 1. Okay? So as I told you, I'm starting with the small numbers, and then I'm going to, use the fractions in the middle. So let me choose x equal 1 this time, and then let's check it out. So plug in 1 onto my question. 1 cubed, 3 times 1 cubed, plus 7, 1 squared, plus 6 times 1 and minus 8. There would be 3, there will be 7, there will be 6 minus 8. Do you think there will be 0? Nope. So you don't really have to calculate fully, but you just, check it that it's gonna be either 0 or not. Okay, what about x equal -1 then? 3 times -1 cubed plus 7 times -1 squared plus 6 times -1 minus 8. -3 plus 7, -6, and -8. Okay, it's not gonna be 0. What about 1/3? X equal 1/3. So 3 times 1/3 cubed plus 7, 1/3 squared plus 6, 1/3 minus 8. I hope this is working. 3 times 1/27 plus 7 times 1/9 plus 2 minus 8. So 3/27 plus 7/9 plus 2 minus 8. And then 3/27 become 1/9 plus 7/9 become 8/9. So it's not gonna be working. So you just really need to choose any number you like and then check it out. That will be 0. So actually our answer is x equal 2/3. I'm gonna show you. So I got 3 2/3 cubed plus 7, 2/3 squared plus 6, 2/3 minus 8. It should be 0 because I know that that's gonna be our answer. So 3 times 8/27 plus 7 times 4/9 plus 4 minus 8. 24/27, 28/9, and minus 4. So this time I can reduce it so that I got 8/9. 28 plus 8 is 36/9 minus 4, which is 4 minus 4, 0. Yay! That's it. Alright, I hope this video helps you. And then, we're going to working on the problem 2 in next video. Bye.